Hello friends, today we will see the random and Gauss error correcting codes. Random and Gauss error correcting code. In this random and burst error correcting codes, in last lecture we have discussed about the some error correcting codes, some error correction techniques, the different types of the error correcting codes. In that we have discussed about the linear codes, non-linear codes, which we can use for the error correction purpose. Also we have discussed about the burst error correcting codes. Now today we will see what exactly the random codes and the burst error correcting codes. First we will go towards the random codes. Random errors, which are the random errors and which are the burst errors. So first we will see the random errors. These two occurs in the transmission errors. Transmission errors are of two types, random errors and the burst errors. Transmission errors. In the transmission errors, we are having the two types of the errors. These transmission errors are nothing but in the form of the random error and the burst error. Okay. So first we will see what is the random error. The random errors are nothing but the errors that occur in a purely random manner. That occur in a purely random manner. These are called as the random errors. Okay. As in the transmission, when there is a occur in a purely random manner, that's why it is called as the random errors. Okay. Regarding the random errors, which different types of the codes, error correcting codes can remove the random error. Basically, the BCH code, BCH codes. When the BCH codes are used to recover the random errors. That is nothing but the BCH stands for both and Hockenberg. These are nothing but BCS codes which are namely used to recover the random errors. These random errors are purely random manner. These are occurring in the transmission medium or the at the time of the transmission. These are nothing but random errors. So that is regarding the random errors. Now we will go towards the burst errors. Next we will see the burst errors. Burst errors are nothing but which are and these are also in the transmission error. These are also at the time of transmission these may be occur. These are nothing but transmission errors. But what we say that when we said that the occurred received message from the transmitter to receiver, that will be having the burst error. When there is a more than one number of errors, more than one number of errors may be occurred, at that time we say that the burst error or the they are coming in the bunches. When there is a bunches of errors, at that time we say that these are the burst errors. When these will be comes due to the effect of impulse noise. Due to the effect of impulse noise. Due to the impulse noise, these errors it may be generated and more than one data bit change their correct value simultaneously. Now more than one data bit value changes, and it changes from 0 to 1 and 1 to 0 more than one times, then these errors are nothing but a burst error. We say that at the time of more than 2, more than 3, these are nothing but a bunches. That's why there is a change in the data. That's why the received word is called as the burst error. The conventional error correcting codes are not effective in correcting the burst error. So, conventional methods. From the conventional method, these burst errors cannot be recovered or cannot be correct the value. That's why we are going for to recover the burst error, to correct the burst error, that is nothing but a special codes are developed for detecting and correcting the burst error, and these are nothing but a fire codes. Fire codes. Fire codes are a special type of the codes which are by using that we can correct. First we will detect the error. First we have to detect the error and then go for the correction of that error. These are nothing but a fire codes. The correction of the burst errors, it may be done by the fire code, and with respect to the random code, random errors can be correct by using the reset codes. These fire codes are nothing but a type of the conventional code. Okay, so we will see the what is the random errors and which are the burst errors and the error correcting codes. Now we will go for some basic definitions of the related to the code words related to the error. Some basic definitions are there. First, we will see the basic definitions related to codes. Basic definitions related to the codes or the code words. Okay. First definition is the code word. What we say? It is a code word. How we can define the code word? Okay. How we can define the code word? So the code word is nothing but n bit encoded block of bits, data bit and the parity bit. Data bit and the parity bit. In the data bit, we are having this is the transmitted code word. This is the transmitted code word or the structure of the transmitted code word. Structure of transmitted code word. See, we are having the data bits and the parity bits, and the total code word is nothing but n bit encoded block of bits. That's why it is k n and n minus k. This is the total n bit code word. N bit code word. And the partition in that we are having it is of k data bits and the n minus k as a parity bits. These parity bits are nothing but a redundant bit array. That's why we can say that we can define the code word in this way as the n number of or n bit code word is having the data bits or the k data bits and the parity bits are of n minus k. A formation of data bits and the parity bits is nothing but a code word. Okay. Whatever the total n bit code word which we have to be transmitted, among that the data bits represented by the k and the parity bits and the or we can say that as redundant bits as n minus k. That is nothing but a structure of the code word. This is called as the code word. In the parity bit there is no any information regarding the data. These are only for the protection bits or for the protection bits. That's why it is called as the structure of the transmitted code word. Yes, remember this, the structure of the code word. Then next definition, now you have the code word. Now you have to clear the concept of the code word. When there is a word you hear as code word, you must remember the structure as n total number of bits, k message bits, and the n minus k parity bits. Okay, that is the code word. Now next definition, code rate. Code rate. Second definition is the code rate. Okay, code rate. Code rate is defined as the ratio of the number of message bits k to the total number of bits n in a code word. Code rate R is nothing but a k by n. Code rate R is nothing but a k by n. Now it is a k, it is nothing but already we have seen in the code word, and k is nothing but a message bits and n are nothing but a total number of bits. Total number of bits. Okay, the whole code word, among that whatever the information, important information which we have to be transmitted is nothing but a k. Okay, and code rate, it is nothing but a, it is the ratio of the message bits, total number of message bits which we want to be transmitted towards the receiver among the total number of bits. Okay, in total number of bits it contains the k message bits as well as the parity bits, k minus n. Okay, that is the code rate. Now it is regarding the code rate. Now the third definition is it is of Hamming weight of a code word. Hamming weight. Hamming weight. It is represented by the x, Hamming weight. W for of the code word. That's why it is represented as the Hamming code word is nothing but Hamming weight of a code word x is defined as the number of non-zero elements in a code word. Number of non-zero elements in a code word. Okay, that is nothing but whatever the number of non-zero elements given, that is nothing but a Hamming weight of a code word x. Hamming weight is represented by W and it is nothing but a number of non-zero elements. For example, we will find a Hamming weight non-zero element in the above is nothing but a Hamming weight. For example, we are having a code word x is equal to 11010011. Total of 8 bits. It is a code word. given code word, we are having a value of 11010011. Now, as per the definition of the Hamming weight, we are having, what is the definition? Number of non-zero elements in a code word. Now we have to find out the non-zero elements as they have represented the 000 each. Okay? But we have to find out the non-zero elements. That's why the non-zero elements are this one, this one, this one, this one, and this one. That's why the Hamming weight of this given code word is nothing but how many ones we have to count. 1, 2, 3, 4, 5. 5 is the code weight of the Hamming weight of this given code word, because number of ones are there 1, 2, 3, 4, 5. That's why weight Hamming weight it is of 5. Okay, yes, clear? That is nothing but a Hamming weight. Now we will see the next definition. Next definition is Hamming code efficiency. Code efficiency. It is the fourth definition. Code efficiency. Efficiency it is nothing but always in the ratio form. Okay. Code efficiency. It is defined as the ratio of message bits to the number of transmitted bits per block. Code efficiency we can represent it by the code rate argument. Code efficiency is nothing but is equal to the code rate, nothing but K by the N. The total number of messages from the code word towards the total number of transmitted code word. Okay. Same as the code rate. As given number of messages, it is a K, and the total number of messages in this N, it contains the K as well as the parity bit size. That's the total code rate among the number of given messages. It is nothing but a code efficiency. Code rate is nothing but a code efficiency. And the last definition from this code, it is the minimum Hamming distance. It is the Hamming distance. Hamming distance. Hamming distance. Okay. Consider for this, we are having one example for this code word first. We have to consider the two code words. Zero one one zero one one zero one, and the another code word okay, we are having a code word 1 and code word 2. Now we have to find out the Hamming distance in between these two code words. How we can find out? See, we have to compare the each bit as we are giving the numbers from the MSB as 0, 1, 2, 3, 4, 5, 6, 7. Okay? These are numbers given from this right to the left. Now match with the each one 0, 0, 1, 0 is there. That's why they are having a Hamming distance. As there is a change in bit 1 and 0 is there. 1, 1 is there. 0, but here it is 1. Another Hamming distance 1, 1, 1, but here it is a 0. Another Hamming distance. Now it is a 0 in the first code word, but in the second code word it is a 1. It is also Hamming distance. Then last 1 and 1. That is nothing but here what is the Hamming distance in between? That is the Hamming distance is that as there is a change in the number of bits. Bit changes from 1 to 0. Here it is of 0, but in the second code word it is of 1. It is of 1 in the first code word, but there is a change in the second code word. That's why the total number of bit changes as 1, 2, 3, 4. That's why the Hamming distance in between these two code words are of 4. Yes? Clear? What is the Hamming distance? This is a very much important concept as Hamming distance. Define the Hamming distance and give the Hamming distance from these two given code words. That's why there is a change in number of bits and with respect to each other as code word 1 and code word 2. There is a change in the bits. That's why the Hamming distance it is a 4 in the given code word. That is called as the Hamming distance. As there is a change in the location in which their respective elements differ. In this way, today we have discussed about some important definitions regarding the code word as well as we have discussed about the random and burst error corrective techniques. For the random errors are nothing but random errors can be defined as they occur in random in nature at the time of the transmission. But the burst error in the transmission they occur due to the bunches as there is a change in the bits from 1 to 0 or 0 to 1. But it is more than one time. So these are nothing but a burst error. Burst error it may be occur due to the noise. That's why to recover the given distance or to recover the error regarding the random error and the burst error, we can use to find out or to correct the burst error, random error, we require a BCH code, and for the burst error correction, we require a firewall. Okay, after that we have discussed about the some definitions regarding the code. In that we have discussed about the definition of code word, code rate, code efficiency, Hamming distance and the Hamming width. So we have cleared all the points. Now today we will stop here.